Well, good morning, good afternoon, or good evening, everybody, and welcome to today's webinar. My name's Richard Smith, and the topic today is the measurement of steep-sided samples. So this is part of a series of webinars called Bearing Solutions, and in this webinar we will have an introduction to steep-sided samples, and then we'll have a look at using data fusion using the method with the Travis unit tilted. We'll then use another method, which is item 3 there, which is tilting the sample, and then finally we'll have a look at the software itself as a demonstration. So let's make some progress now, and we'll start with the introduction. When we're measuring samples, the stylus needs to be able to traverse the sample without touching the sides of the stylus. In other words, in the picture on the left, the stylus tip is not in contact with the surface all the way around the sample. And you can see what's happened there. In the middle section, it would probably be okay, but as it heads up towards the right-hand side here, you can see that the tip is not contacting, but the side is. So clearly, there's a relationship between the slope of the sample and the angle of the stylus tip. Now, typically on a standard 60-degree included angle stylus tip, we can measure realistically up to an angle of about 45 degrees. But if we want to overcome that, and we've got samples like this one, which are quite steep, maybe 70 or 80 degrees, what we can do is we can tilt the sample, or as in this case, we can tilt the measuring instrument, tilt the Travis unit relative to the sample. And you can see clearly now that we're going to be able to measure all the way up onto this edge. Now in this case, we're not going to be able to measure the left-hand edge, but we'll come to that in a minute. But this shows clearly that tilting the sample or tilting the Travis unit allows us to measure the steep slope. So here's an example. This is an angular contact bearing, and in this case we've got it mounted horizontally, and you can see the same thing has happened again. The stylus will have been able to measure along this section here, but when it reaches the right-hand side, flanking will occur, and so the results that we get will not have any meaning. So what do we do? Well, the simplest solution in this case is just to tilt the sample. In this case, we've tilted it at about 45 degrees, perhaps 35 degrees there, and it allows us to measure all the way along the top surface, along the surface here, onto the bearing raceway, and then onto the steep section as well. And let's just have a look at that in practice. So here's the stylus starting to measure now. And as it comes onto the raceway and onto the steep section, the stylus is able to measure that very steep part of the slope. The important thing to note here is that we're only dealing with a steep slope on one side. So the question is, what happens in other situations where we've got two sides which are have very steep slopes? And you can see that in this example here. On the right-hand side, it's very steep, and on the left-hand side. And what we've done here is to tilt the Travis unit, and obviously we'll be able to measure from the left, just left of center, over onto the right-hand land marked at B. Well, what we can do is rotate the sample through 180 degrees, and then that allows us to measure the other side. So we've done two measurements. The first measurement from A to B over center, and rotate it 180 degrees, and another measurement. Now, combining those measurements and using Taylor-Hobson's Metrology 4.0 data fusion software, we're able to fuse the two traces together. And so this allows us to measure steep sides. Things to think about here are the stages that are used. They need to be good quality stages and well aligned, and the type of fixtures as well. We also need to think about what we're using as datums. Sometimes we may need an external datum on the fixture. The Travis unit angle chosen will depend on the sample itself, as will the choice of stylus. PGI Novus system from Taylor-Hobson allows us to align samples very, very well. And the smaller the sample, generally, the more important is the alignment. The other consideration is how much overlap to do at the center. If we don't go over the center on our measurements, then we won't be able to join the traces together. So there's an example of tilting the Travis unit and fusing two traces together using data fusion software. We'll now have a look at another example where instead of tilting the Travis unit, this time we're going to tilt the sample. And this is a groove in a surface. It could be a ceiling surface, for example. And so it's an example of a region on a sample that cannot be measured in a single trace due to stylus flanking. In fact, it's even more difficult than the previous one we looked at. At least it looks like that. It's got 90-degree slopes on the left-hand side and on the right-hand side. So the interest here is in measuring the width, the drop, the height, and some of these angles as well of these chamfers, and the depth of, and the fillet radii as well. So we want to measure the whole part, but really, even if we were to tilt it at 45 degrees, we'd only be able to measure one side at a time. But by fusing it together like this, we can achieve what we want. So what we do is we tilt the sample as shown here, and we're able to measure this side. And you can see we've got a tick marked there showing that this data is valid. In this case, this data is not valid on the right-hand side. So that's tilted the sample anti-clockwise. We now repeat the process and we tilt the sample clockwise, and we're able to measure on the right-hand side here, the right-hand side of the slope, that data is now valid, and the data on the left-hand side is not valid. Using data fusion software, we're able to combine these two traces together to get exactly the result we want. And here's the completed profile. So we're looking at the distances, we're looking at angles, we're looking at the fillet radii, and also you can just see there we've got some tolerancing done, and we've toleranced the fillet radius, and we've looked at the form error. In this case, it's showing it's 17.4 microns. So this example was tilting the sample. So we've looked at tilting the Travis unit, and we've looked now at tilting the sample. So now, finally, we're going to have a look at the demonstration of using the data fusion software. And in this case, we're dealing with some very steep-sided grooves. These are 70 or 80 degrees, between 70 and 80 degrees. And these are the sorts of grooves that could be used in a typical fuel cell, but not necessarily just that application. It could be many other applications, anything with steep sides. But the central region is quite big here and quite flat. And so instead of fusing two traces together, in this case, we're going to fuse three traces. And what we're going to do is to take three traces, one with the Travis unit horizontal, and we get this result where this data that I'm pointing to now in the center is valid. And then we tilt the Travis unit again at about 30 degrees, and the data on the right-hand side is valid. This data is not valid. And then we rotate the sample and we measure again, allowing us to get the data for the left-hand side. So we've got three pieces of data that are good. the central trace here, the right-hand trace here, and the left-hand trace here. And what data fusion does now is to fuse these three together. And we'll just take a look at that. So in Metrology 4 software, we're showing you the process. This would be fully automatic. We're just showing you the process here. So what we've got here is two traces. And we're going to fuse the right-hand trace to the center trace. We automatically detect the traces and we carry out the fusion process, and there it is. The result then appears. So what we've done so far is to fuse just two of the traces. We've fused the center trace to the right-hand side trace, but we've not yet done the left-hand trace, and here it is, the one we now want to fuse to this. So this is the second operation. As I say, this would normally be automatic. I'm just showing the process here. We're now going to fuse these two traces together. We select them. We activate the data fusion. There are the two traces at the top there. We automatically detect them and we fuse them together. And finally, we have the result that we want there. So there is the full profile with valid data all the way around these traces. We're just going to move on to a summary now of what we've looked at. So data fusion may be used when sample sides are too steep for a conventional single trace, where stylus flanking occurs. It's available on Taylor Hobson's range of surface instruments in Metrology 4.0 software. And as we've just seen, multiple profiles can be fused automatically. One of the things to think about is having suitable stages, fixtures, and datums. I'm going to pause at that point and just ask if anybody has any questions, and I'll try to answer those as best I can. Can't see any questions today, but thank you very much for listening and taking your time to join this webinar. Look forward to meeting you again in future webinars. Thank you very much and goodbye.